A crate of mass 3.5 kg is pulled at constant speed along a horizontal floor. The pulling force is a magnitude of F Newton, acts at an angle of 14 degrees above the horizontal, like this picture here we have. And the normal component of the contact force is 20 Newton. And we are asked to find the work done by the pulling force in moving the crate a distance of 3 meters. Okay, what do we need? Well, we're going to find the work done. So please remember that work is done when a force moves a point of application in the direction of the force. So let's start by looking at this picture. I have resolved the force F into its two perpendicular directions. I have my F cos 14 and my F sin 14. What are we doing here, right? We are trying to indicate all the forces acting on this crate. In physics, we call it a free body diagram. Now, if you're not doing physics, don't worry about it, but that's what is called in physics. This is a free body diagram where we indicate all the forces acting on the object. So we have the normal reaction. I've labeled it R, and remember they gave us the value 20 Newton. I've already resolved the forces into its two components, force F into F cos 14 and F sin 14. You don't want to spend too much time resolving forces, yeah? So if they give you a force, let's say 6 Newton, and I have 20 degrees, straight away this is 6 cos 20, okay, and this is 6 sin 20. Yeah, you don't want to spend too much time trying to figure out Pythagoras theorem and opposites and adjacents and hypotenuse and so on. So you want to go straight for the kill. Great. And then you have the gravitational pull, the weight 3.5 g. Okay, and I've also drawn a picture here to indicate that this object is going to be moved a distant 3 meter horizontally. Okay, great. Excuse me. First, let's deal with the vertical forces. This object is not going to move anywhere as far as the vertical directions are concerned. So we have summation of forces in the y direction will be 0. So I have got, what are the forces in the y direction? In the vertical direction, I have got R, I have got F sin 14, and there are only two forces in the y direction going upwards. Downwards we have 3.5 g. That's what you see here. Okay, sum of forces upwards equals to sum of forces downwards. So we write R plus F sin 14 equals to 3.5 g, and then you can work out the value of F directly if you like, okay, because we know g is 10, so you can have F equals to bring the R over and divide by sin 14. I just left it as this, yeah, 15 over sin 14. Now that we know the value of F, we can work out the work done. Remember, motion is in the horizontal direction, so we are going to use the component of the force in the horizontal direction. So that will be F cos 14. So we're going to take F cos 14 times 3 and we'll be done. Okay, so we have the work done here will be F cos 14 times 3. Use a calculator, clean this up. Okay, I have used my calculator at the very end. I decided to simplify these things first. Okay, you can just go ahead and plug the numbers in and work out the value as 180 joule. Okay, we're done with the first problem. What do you guys think? If there's any question, talk to me. Yeah, I think that if you do come across questions like this on the exam, I think it's important to get a good hold on resolving forces and remembering that work done is always F times D, where remember F and D will always be in the same direction. That's the definition of work done. Otherwise, I think this is a pretty straightforward problem. So if you have a question, you can either text me or you can speak up, okay, if you have facilities with your computer. We are going to move on to number 2 in a minute. Mark, you okay, Mark?
Yeah, we don't have anything to do with any friction on this question.
No, there no mention of any friction at all.
Okay.
There can be a problem where I think on my other handout, I think I think if I'm not mistaken, yeah, I think there's something that involves friction and work done on the other handout. But in this particular problem, none at all. Jalene, I hope you're okay. Okay, we're going to move on to the next question, come, so that we can pick up the pace here.